Hello. Today I want to talk to you about the second video in my mini-series. The first one was plasma surface treatment, and today I want to talk to you about how the effects of the treatment are measured. Hello, my name is Greg Friedman, and on this channel I talk about sciencey stuff with a plasma twist to them. So water contact angle measurement. You know, this technique is probably as old as time. You know, you take a thing, dip it in water, and water just runs off it. Well, it's hydrophobic. You take a different thing, put it in water, and water just soaks right in. Water loves it. The thing is hydrophilic. You take a surface and put a drop of water on it. Drop just beads up and kind of rolls off the surface. Well, the surface is hydrophilic. You take a drop, put it on a surface, and the drop just soaks in. Well, the surface is hydrophilic. Simple, right? Stupid simple. And believe it or not, that is probably the #1 measurement employed in the industry to see if the plasma treatment is working, to see if the surface is ready for gluing, etc., etc., etc. So how does this work? Well, you take a really small droplet, or not really small droplets, let's say a millimeter or 1/16 of an inch droplet. How do you get that droplet? Well, probably some kind of syringe, or better, syringe with very precise tip and a very precise motor that measures out the exact same volume of liquid every time. And when the drop hits the surface, there is a special device that looks on the side and looks at the angle, right? High angle, so that the droplet is sitting like a circle. So high angle means the surface does not like the water, it's hydrophobic. And low angle, water droplet is sitting very flat. Well, that means the water spreads more easily, so the surface is hydrophilic. So this method is actually really practical for measuring wettability of the surface. If the surface is ready for gluing, painting, sticking things to, or otherwise processing it. So why do droplets have different shape? Well, water molecules are pretty cool. They cohere, they like each other. They're hanging onto each other while they cohere to each other and adhere to the surface. So they're glued to the surface, but kind of holding hands with each other. And what the surface is, the surface, surface roughness, surface energy, that determines how much of the water adheres to the surface. Water also has pretty strong surface tension of the droplet itself, so how that water interacts with the surface defines the shape of the droplet. And the surface energy and surface chemistry, they strongly influence the shape of the droplet. For example, after plasma treatment of almost any surface, the contact angle decreases. So, you take a nicely polished metal surface, put a droplet of water on it, and it'll sit like a sphere. But you plasma treat it, put a droplet of water, and the droplet spreads. So the contact angle changes. And there is a device that humans engineered to measure these things. It's called Goniometer. The Goniometer image, it's a combination of syringe that makes the droplet and a camera that looks at the droplet and the software that processes it. So you can imagine that this device is very, very sensitive to what the water is. And I'll talk in the next video about how fascinating water actually is, just simple water, how complex it is. And the more I study it, the less I understand it. But anyway, The water matters, the orifice matters, and the pump matters. The camera almost doesn't matter. As long as it's good resolution camera and good processing software, you'll get a pretty good results. Usually you need to put multiple droplets on different areas of your material to kind of average the result, or look at how uniformly the surface is treated. So you can imagine consistent water drops, that the consistency between the drops and consistency between your water sources matters. So actually these devices can be very expensive, reaching, tens of thousands, many tens of thousands of dollars, coming in calibrated with regular calibration. The pump needs to be extraordinarily precise. The tube, the syringe that makes the drop needs to be very precise and calibrated. And usually these systems come with their own special fluid. It's whatever they formulated. Usually it's water with some additives, but this gives you a calibrated, precise measurement today, a month ago, or a month from now. Now, how do we interpret the results? Because look, with my earlier example, you dip something and the water doesn't like it, and you dip something else and the water likes it. Well, wettability doesn't really tell you everything. It just tells you the surface is more wettable, but it doesn't tell you why. It doesn't tell you if the surface chemistry changed or the surface roughness changed. It doesn't tell you how permanent. Well, I guess it could. So if you do droplet now, 1 hour from now, 10 hours from now, so you can actually, I guess, that way measure how the surface wettability changes over time. It just doesn't tell you why. And also, contamination is a big issue for these measurements. You can imagine a microscopic speck of dust on the surface will change your measurement. Sticking with plasma treatment, the plasma-treated polymers, they age. So the water contact angle will change. So the best practice in this field is use the best equipment you can afford, and also do as much statistics as you can, multiple samples, compare samples under the same protocol, calibrate your devices regularly. But it's funny to me how we keep engineering and re-engineering an ancient method, and it's still, to the best of my knowledge, simplest and most widely used method in the surface treatment industry. Anyway, this is it for the second video in the series. Next one, I'll talk about what I touched up on water properties in this video a little bit. In the next one, I'll talk more about it. And I'm also happy to entertain any of your questions or comments down in the comment section below. Please feel free to ask any questions. If I can't answer them, I will, or I will try. Thanks, guys. I'll see you in the next one. Peace.